Hi, in this video, we are going to do some solved problems on ellipse. So we have already discussed the entire theory for the ellipse topic in the last two videos. So I wanted to do some problems for you so that you can revise all of the concepts. You should try all of these problems yourself before you listen to the solution. So when I state a problem, try and pause the video and solve it yourself, and then you can look at the solution, right? So let's begin. The first question is, find the equation of the ellipse. Equation of ellipse whose focus is 0, 3, eccentricity is 3/5, and directrix is 3y minus 25 equals 0. So for some of these problems, I will tell you the method and then you should solve it yourself. So here, if the focus and directrix are given and eccentricity is also given, obviously we should use the property PS is equal to EPM. PS is the distance from the point XY to the focus. So we will do distance of XY from this. So that will be X minus 0 whole square plus Y minus 3 whole square root over that is equal to 3/5, and distance of the XY point to the directrix. So that will be 3y minus 25 by root over 9. This is my standard equation. And if you square it, you will get the final answer. Square it and simplify, you should get 25x square plus 16y square is equal to 400. So this is a pretty easy question based on the definition. Okay, let's try the next one. Question number 2. Find the equation of the ellipse. Equation of the ellipse whose latus rectum has length of 15/2 and the distance between the foci is 2. Between the foci is 2, the axis being the coordinate axis. So major and minor axis are along the coordinate axis, x and y. You have latus rectum's length is given and the distance between the focus is given. So if you have a standard ellipse like this, we have studied that the length of the latus rectum is going to be 2b square by a, because the endpoints of the latus rectum are ae comma b square by a and ae comma minus b square by a. So this is something that we have discussed. So 2b square by a is equal to 15/2, and the distance between the foci, here the distance between the foci for this ellipse is 2ae is equal to 2. So we have these two relations, and from here we have to find a and b, right? Now we also know that b square 1 minus b square by a square is equal to e square. So that is also a result that you should know. So from here we get ae is 1 and a square e square is also 1. So you get a square minus b square is equal to a square e square from here. So a square minus b square is also 1, which means b square is equal to a square minus 1. And you can use that here now because b square by a is equal to 15/4. So now we get a square minus 1 by a is 15/4. So this is simple. A minus 1 by a is 15/4. And that is obvious that a should be 4 now. By seeing the equation itself, we can see that 4 minus 1 by 4 is fitting, right? So if a is 4, b square is equal to 16 minus 1, 15. B square is 15, a square is 16. And the equation of my ellipse becomes x squared by 16 plus y squared by 15 equals 1, right? So these are standard facts of an ellipse that we know: the distance between the foci, the length of the latus rectum, and that's how we solve this problem. The third question is this one: find the equation of ellipse whose center is 4 comma minus 1. Center is 4 comma minus 1. And one end of major axis is minus 1 comma minus 1 and passes through the point 8 comma 9. The point 8 comma 9. So think about it. The center of the ellipse is 4 comma minus 1 and one end of the major axis is point A, let's say, is minus 1 comma minus 1. So notice that both the center and the major axis are on the same y is equal to minus 1 line. Y is equal to minus 1 becomes the equation of the major axis, right? And the other end of the major axis, you should know that the center is a point such that it will bisect any chord on the ellipse. So if one end is minus 1, the center is 4, minus 1, we can find B, which is x comma minus 1. So x plus minus 1 by 2 is equal to 4. So x minus 1 by 2 is 4, so x is equal to 9. So this is 9 comma minus 1. And from here we get that 2a, the major axis length, is 10, right? So we are getting a is equal to 5, the length of the semi-major axis, right? Okay. Now equation of this ellipse, since it is a shifted ellipse whose center has been shifted, would be something like this: x minus h whole square by a square plus y minus k whole square by b square is equal to 1, where you will write it as x minus 4 whole square, but a square we already know is 25, plus y minus minus, so y plus 1 whole square by b square is equal to 1. So we have gotten so far here using the center and the fact that the major axis one end was given. Now there's another piece of information that 8 comma 9 lies on the ellipse. So if 8 comma, actually I have made a mistake. 8 comma 9 is not the point. The point is 8 comma 0. So if 8 comma 0 lies on the ellipse, you can put that in this equation, and from there you should be able to find the value of b. So if you calculate it out, you will get b square is equal to 25 by 9. How do I get that? You put x is equal to 8 and y is equal to 0 in the ellipse equation here. The only unknown will be b square, and you will find that, and therefore the equation of the ellipse can be derived now. The final answer will be x minus 4 whole square plus 9 times y plus 1 whole square is equal to 25. You can check that with your calculations, right? I hope you have understood the solution. Let's move on to the fourth problem. Find the equation of the ellipse whose eccentricity is equal to half, center is 2 comma minus 1, and latus rectum is equal to 4. So again, a lot of data has been given. Length of latus rectum 2b square by a is equal to 4. So we know b square is equal to 2a, right? And eccentricity has also been given, right? So b square is equal to 2a, and now eccentricity is 1 minus b square by a square, square root of that. So that is half. We get half is equal to 1 minus b square by a square, half square. So 3 by 4 is equal to b square by a square. And from here we get b square is equal to 3 by 4 a square. And if you combine this with this, you will get 3 by 4 a square is equal to 2a. A cannot be 0, so 3 by 4 a is equal to 2. So a is equal to 8 by 3. Right? Once you get a, you will also get b, because b square will be equal to 16 by 3. So b will be equal to 4 by root 3. Right? So the equation of the ellipse is now easily, right? You can write it easily. It will be x minus 2 whole square by a square, which will be 64 by 9, plus y plus 1 whole square by b square, which is 16 by 3, is equal to 1. Why did I do x minus 2 and y plus 1? Because the center has been shifted to 2 comma minus 1, right? So this becomes your final equation. You can simplify it by multiplying with appropriate constants. Okay, let's move on. Question number 5. Find the equation of the ellipse whose vertices are 5 comma 0 and minus 5 comma 0, and whose focus lies on the line 3x minus 5y equals 9. Okay, so when I say vertices, I mean endpoints of the major axis. So the two endpoints are given as a, which is 5 comma 0, and a dash, which is minus 5 comma 0, which automatically implies 2a is equal to 10. So a is equal to 5. So we get that already. So we know that focus of this ellipse would be at plus minus ae comma 0, right? So since it is plus minus ae comma 0, we have plus minus 5e comma 0 is the focus, and that focus will satisfy this line equation, right? So we will get plus minus 15e minus 0 is 9. So you'll get plus minus 15e is 9. So e is coming out to be plus minus 9 by 15 or plus minus 3 by 5. But e cannot be negative. That means we should reject the negative case. So here we have e should be 3 by 5. And once you get e as 3 by 5, you can find b square is equal to a square 1 minus e square. And b square will come out to be 16. And from here we get the equation of the ellipse. The equation answer would be x square by 25 plus y square by 16 equals 1. So another concept here, the vertices of an ellipse are usually the endpoints of the major axis. So you should know that. Okay, let's go to the next problem. We have two equations in these questions. One equation is this, 3x square plus y square minus 6x minus 2y minus 5 equals 0. And the second equation is x minus 2 whole square plus 2 times y plus 3 whole square is equal to 8. And our question is to find length of major axis, minor axis. We have to find latus rectum's length. We also have to find the eccentricity of this curve, center, foci, and equations of the directrices. So basically everything about these two curves, right? Okay, so let's think about it. The first equation is 3x squared minus 6x plus y squared minus 2y minus 5 equal to 0. I want to complete the square here. So I'll say 3 times x squared minus 2x plus 1. So I have added a plus 3 here. So I have to do a minus 3 plus y squared minus 2y plus 1. I have to do a minus 1. Minus 5 is 0. So I'm getting 3 times x minus 1 whole square plus y minus 1 whole square. And I have a minus 4 minus 5 minus 9 is equal to 0. You get x minus 1 whole square by 3 plus y minus 1 whole square by 9 is equal to 1. So basically I'll take 9 on this side and divide by 9. So this is what my equation is coming. So notice here that this is the equation of the ellipse. Here a square is 3 and b square is 9. So a is less than b. So it's an ellipse of this form. It is an ellipse with its axis parallel to the y-axis. And the major axis will be 2b. Major axis will be 2b. And 2b is equal to 6, minor axis is 2a, and that is 2 root 3. The eccentricity is E is root over 1 minus, now it will be a square by b square, so that is 1 by 3. So eccentricity will be root over 2 by 3. And latus rectum, the length of latus rectum would be this length and this length. So that will not be 2b square by a, it will be 2a square by b. So that would be 2 times 3 by b is 3. So length of latus rectum is simply 2, right? Center of this ellipse is the displaced point. It is at x minus 1, y minus 1. So center is 1 comma 1. And now the equations of the directrices. The directrix equation will be y is equal to b by e, but you have to shift it up by k, right? So k plus minus b by e is the equation of the directrix. So k is 1, so 1 plus minus b by e. So 3 by e is root over 2 by root over 3, right? So equation of the directrix becomes y is equal to 1 plus minus 3 root 3 by root 2. That becomes your equations of the directrices. Focus will obviously be k. The equation of the position of the focus is h comma k plus minus be, where h and k are 1 and 1, which is shifted with the center. So you can find that yourself. It is pretty obvious now what has happened. So the standard method in such equations is basically converting it by making it a perfect square and writing it like this, and then noting the form of the ellipse, whether it is A is greater than B type of ellipse or whether A is less than B. Similarly, in the other question, if you have x minus 2 whole square plus 2 times y plus 3 whole square is equal to 8, this is x minus 2 whole square by 8 plus y plus 3 whole square by 4 equals 1. So first of all, center of this ellipse is 2 comma minus 3. Major axis, which axis is the longer axis? This is bigger. A is greater than B. Major axis is 2a. A square is 8. So major axis is 2a, which is 2 times root 8. So 4 root 2 actually. And b square is 4. So minor axis is 2b, which is 4. Minor axis. Eccentricity is 1 minus root over 1 minus 4 by 8. So 1 over root 2. That is the eccentricity. Again, latus rectum's length will be 2b square by a here. So that will be twice of 4 by root 8. So that will be equal to root 8. And then foci. Foci would be h plus minus ae comma k. And here h and k are the shifted centers coordinates. So it will be 2 plus minus ae. A is root 8 times eccentricity is 1 by root 2. So 2 root 2 by root 2. So it is 2. And k is minus 3. So basically the foci are coming out to be 4 comma minus 3 and 0 comma minus 3. These are the foci, right? An equation of the directrices, will be x minus h. So x will be equal to h plus minus a by e. So you can calculate that again. H is obviously 2 and a by e we have already found out, right? So that becomes your solution for this particular problem. Let's move on to the next question. This one was question number 6, I think. Yeah. So this one was question number 6. We will move on to now questions not about just the equation of the ellipse. We'll move on to questions where we have tangents and normals and the other properties that we learned about. Question number 7 is find the equation of tangents to the ellipse 2x square plus y square is equal to 8, which make 45 degree with the major axis. right? So notice here that x squared by 4 plus y squared by 8 is equal to 1. So the major axis of this ellipse is the y-axis. Y-axis is major axis. So our tangent is making 45 degree with the major axis. So actually y-axis, if you make 45 degree, it is still 45 degree with the x-axis. So slope of the tangent is either you could be this side or you could be this side. So slope could be plus or minus 1, right? Because you could have been, tangent could have been like this or like this. The angle would have been 45 or 135. So the slope of the tangent is plus or minus 1. Equation of the tangent is mx plus minus root over a square m square plus b square, right? So in this case, you will get y is equal to plus or minus 1x plus or minus root over m square is 1. So 4 plus 8, so 12, right? You'll get y is equal to x plus 2 root 3 or x minus 2 root 3. These are the two possible equations with m is equal to 1 and m is equal to minus 1. You'll get this or this, right? Okay, let's move on to the next problem. Find the equation of tangent and normal to ellipse x square plus 2y square minus 4x plus 12y plus 14 equals 0 at the point 2 comma minus 1. So obviously we'll use the replacement method here because the point is given and the curve equation is given. So instead of x square, I'll write x1 plus 2 times y1 minus 2 times x plus x1 plus 6 times y plus y1 plus 14. That will be the equation of the tangent. So putting the value, you get x1 is 2, so 2x plus y1 is minus 1, so minus 2y minus 2 times x plus 2 plus 6 times y minus 1 plus 14 equals 0. So this becomes 2x minus 2y minus 2x minus 4 plus 6y minus 6 plus 14 is equal to 0. X gets cancelled and you have 4y. This is minus 10, so plus 4 is equal to 0. The equation of the tangent is y plus 1, y is equal to minus 1. Y is equal to minus 1 is the equation of the tangent. So obviously the line that is perpendicular to it would be the normal. So that would be some x is equal to k. And it has to pass through this point at 2 comma minus 1. So normal would be x is equal to 2. Right? So normal is x is equal to 2 and tangent is y is equal to minus 1. So that becomes the equation of tangent and normal. Right. Next question is ninth one. Find the point of contact of the tangent line four x plus y minus 7 equals 0 with the ellipse x square plus 3y square is equal to 3. So here we already are given the tangent line equation and we have the curve equation. The way to find the point of contact is simply to solve the tangent equation with the curve. And when you solve that, you will get discriminant should be 0, automatically it will come. And whatever is the answer will be the single point of contact, right? So here, how will we solve it? We can put y is equal to 7 minus 4x and we can put that in this equation. So you get x square plus 3 times 7 minus 4x whole square is equal to 3. So this becomes x square plus 3 times 49 plus 16x square minus 56x equals 3. So you get 48x square plus x squared. So 49x squared minus 150 minus 168x plus 49 into 3 minus 3. Right? So 48 into 3 will be there. 144 is equal to 0. Right? We are getting this situation right now, and we can solve this equation for x. So x would be equal to 168 plus minus root over b square minus 4ac. So 168 square minus 4 into 49 into 144. This discriminant should be 0 actually. So 2 into 49 should come. You should check this. 168 was 56 into 3. So it is 56 square into 9 minus this is 16, 64 into 49 into 9. So 64 into 49, notice that this is 7 square and this is 8 square. So that is 56 square. So clearly the discriminant is disappearing. So you're getting this x is equal to this. So this is 84 by 49. And 7s are 12 and this is 7. So x is coming as 12 by 7. The point of contact. And if x is 12 by 7, y is equal to 7 minus 48 by 7. So it is 1 by 7. The point of contact is 12 by 7 comma 1 by 7. And I didn't need to check this because it was said that it was tangent. So I could have just done solution of this would be b by 2a. X is equal to b by 2a, which is 168 by 2 into 49, right? Directly. So that is how you find the point of contact. Now, the next problem says find the coordinates of the points on the ellipse x square plus 3y square is equal to 37, at which the normals are parallel to the line 6x minus 5y equals 2. Okay, fine. So normals are parallel to this line. So obviously tangents will be parallel to a line perpendicular to this, right? Which will be 5x plus 6y equals k. So tangents will be perpendicular to 5x plus 6y, or you can even say 5x plus 6y plus k equals 0. This line is perpendicular to this line. So from here, what we get is slope of the tangent m is equal to minus a by b, so minus 5 by 6, right? Okay. So what we can now say is this line is tangent, or this line is tangent to the ellipse. 5x plus 6y plus k equals 0 is tangent to the ellipse x squared by 37 plus y squared by 37 by 3 equals 1. So the condition for this line to be tangent to the ellipse is a square L square plus b square m square plus is equal to n square. What do I mean by this? So generally, if you have Lx plus my plus n equals 0, is tangent to x square by a square plus y square by b square is equal to 1. This is a standard line tangent to ellipse. We can do the same thing that we did in the previous problem. We have to solve the line with the curve equation and say that for tangent, discriminant should be 0. Now, what I want you to do is you can check this out. If you do Lx is equal to minus my minus n, and x is equal to minus my minus n by L. And you take this and put it in this curve here for x, you will get a quadratic in y. Check the discriminant of that quadratic. Discriminant is equal to 0. Condition for that quadratic will give you this result. A square L square plus B square M square is equal to N square. So this is a result that is sometimes useful. So you might as well remember it, because it might be annoying to try to do it in a real question. For example, here we have the line 5x plus 6y plus k equals 0 is tangent to the ellipse equation is x square by 37 plus y square by 37 by 3 equals 1. Now here L is 5, M is 6, and N is k, right? And A square is this, and B square is this, right? So for the line to be tangent to the ellipse, you need to have A square L square. So 37 L square, which is 5 square, plus B square M square. So B square is 37 by 3 into M square, so 6 square, is equal to N square, so is equal to K square, right? So from here, we can say that 37 common, and you get 3 into 25 plus 36 by 3, right? So notice that this is 75 plus 36. So this is 111 by 3, and that is 37. So k square is coming out to be 37 square. So you're getting k is equal to plus minus 37 from here, which means the equations of the tangents become 5x plus 6y plus 37 or minus 37. These are the equations of the tangents, right? And the point of contact here would be the point of contact of this line with this curve. Again, you just have to solve the line with the curve, and you can remember this result, that the point of contact of Lx plus my plus n is equal to 0 with the standard x square by a square plus y square by b square equals to 1. If this line is tangent, then the point of tangency is minus a square L by n and minus b square m by n. So this is the point of tangency. It comes again after solving the quadratic and seeing that discriminant is 0. You can verify that yourself. If you put in the values now, minus a square L by n and minus b square m by n, you will get the values of the points of contact. And that is what the question was asking us. Okay. So try it out. The required points should come out to be 5, 2 and minus 5, minus 2. These are the two options, right? So we will move on to the next problem now. This is problem 11. We have show that the common tangent of the ellipse of 3x square plus 13y square is equal to 78, and circle x square plus y square is equal to 16 is inclined at 45 degree to the major axis. So we have to find the common tangent to the circle and the ellipse. Now, since it is a tangent to the circle, we know from circle properties that the equation of the tangent will be mx plus minus a root over 1 plus m square. So it will be y is equal to mx plus minus a is 4 root over 1 plus m square, right? This is my tangent equation for the ellipse, and for the circle, and here we have the equation is x square by 26 plus y square by 6 equals 1. And this line, remember this line equation can be written as mx minus y plus 4 plus minus 4 root over 1 plus m square is equal to 0. So using the result that we just now saw, if we call it as Lx plus my plus n and equals 0, and that line is tangent to this ellipse, we should have a square L square plus b square m square is equal to n square. Here L is small m, right? And a square is 26. So 26 times small m square, and b is 6, so plus 6 times capital M square would be minus 1 square. So 1 is equal to n square. N square would be 16 times 1 plus m square, right? So you're getting 26 m square plus 6 is equal to 16 plus 16 m square. And from here we are getting 10 m square is equal to 10. And m square is equal to 1. So m is equal to plus minus 1. So the equation of the common tangent is x minus y plus 4 root 2 equals 0, or minus x minus y minus plus minus 4 root 2 is equal to 0. Right? These are the two different types of tangents, and notice that slope of the tangent is either 1 or minus 1, so it automatically makes 45 degree or 135 degree with the major axis, right? So we have done that. And again, we are using this result that the line is tangent to the ellipse. The condition is this. The condition comes by doing discriminant equal to 0 when you solve the line with the curve. Okay, let's move on. Question number 12. Find the equation of tangent drawn to the ellipse x square by 3 plus y square is equal to 1 from 2 comma minus 1, from the point 2 comma minus 1. So we can say the equation of the ellipse will be y is equal to mx plus minus root over a square. A square is 3 m square plus b square, right? So this is the equation of the ellipse, and it has to pass through 2 comma minus 1, right? So we'll say minus 1 is equal to 2m plus minus root over 3m square plus 1. And this will become, if you take this 2m on this side and square it, it is a quadratic in m. If you solve the quadratic, you will get the possible values of m. M possible values are 0 and minus 4. And the required tangent lines are y is equal to 1 and y is equal to minus 4x plus root 49. So you should do that yourself. The steps here are pretty obvious, so I will not discuss it further here. Now, question number 13 is this problem. It says, if the normal at an end of a latus rectum of the ellipse passes through one end of a minor axis, show that the eccentricity of the ellipse is given by e power 4 plus e square minus 1 is equal to 0. This is a very standard problem. This is a problem that has been taken from SL only. So what we have is a situation like this. Let's say we have a latus rectum here. I want to make the tangent at endpoint of a latus rectum, this point, and then normal. And normal at this point is supposed to pass through the end of a minor axis, right? So what I'm saying is normal to this point P, this point is AE comma B square by A, right? The normal at this point passes through the endpoints of the minor axis, so 0 comma minus B, right? And in that case, we have to prove this result, right? So equation of the normal usually is a square x by x1 minus b square y by y1 is equal to a square minus b square. And x1, y1 for us are ae and b square by a. So you have a square x by ae minus b square y by b square by a is equal to a square minus b square, right? So this becomes x ax by e minus b square cancels minus ay is equal to a square minus b square. This is the equation of the normal, and this normal is passing through a particular point. Which point? 0 comma minus b. So what we know is we put x is equal to 0 in this and minus b, it will satisfy, right? So we are getting 0 minus minus plus ab is equal to a square minus b square, right? So I have the result AB is equal to a square minus b square. If AB is equal to a square minus b square, I can write it as a square b square is equal to a square minus b square whole square. And then b square can be written as a square into 1 minus e square. And here we have a square minus b square whole square. So we can also write a square minus b square as a square e square, right? So this side also we can write a square e square whole square. So this becomes a power 4 e power 4, and this side is a power 4 1 minus e square. A power 4 will get cancelled, and we have e power 4 is equal to 1 minus e square. So e power 4 plus e square minus 1 is equal to 0. So this is a very important property. It's a standard property, and the question is very old. You should know this, that if the normal at the end of a latus rectum passes through the minor axis endpoint, then we'll get this result, right? It's standard property coming from the equation of the normal. Once you know the equation of the normal, it was pretty straightforward what we did after that, right? So I will stop at this point. We have discussed 13 questions. Many of the questions were about equations of the ellipse, and some last few questions we did were tangent and normal. In the next class, we'll do one more session of problem solving on ellipse. It will cover the parametric forms and other properties of ellipse that we have seen so far. So one more problem solving class will be done for ellipse, and then we'll conclude the chapter and move on to hyperbolas. So that's it for this video. I'll see you next time. Stay tuned for the more content. And if you like the content, please subscribe to the channel and like the videos. Thank you.